Right, we are live. Ben, say
Hey,
something. Let's see if audio works. Testing 1 2. My
are we
audio probably
here?
works.
Are we here?
Yeah,
Yep.
it's live now. Can you say something?
It says live, so uh, I'm just checking. You can see here I'm doing it on my own screen.
You're going to
We'll
start an
probably,
infinite
probably hear
loop,
an
and then
echo.
we'll fall into the center of the earth.
That's right.
Somebody said, "Can hear Ben and Bill." Is Ben echoing?
I'm getting echo.
But you can't do
Yep.
that because you hear me natively. Ben has an echo,
I'm hearing
so
you just.
yeah, I don't know how to fix your echo. Get that. Yeah, I don't know how to turn off the screen share.
It's frozen. Skype froze. I did.
Yeah,
I can hear you, but nothing's happening from my end.
yeah, you're frozen. You went into an infinite loop when you tried to share the feed. Yeah, everybody's saying echo. We can't do this today. I have no way to fight the echo. Here. Okay, I have one thing to try. Now, everybody, does Ben? Can you hear Ben? Ben, start talking.
Oh, I can still hear you, but I'm looking at my Skype call and all the video's frozen
Yes,
from
it is.
you.
I agree with that statement. But
But I can
keep
hear you
talking.
just clear. I can hear you totally clear.
Right, and
I could
so
hang up Skype and join again.
yeah, let's see. Good now. Okay, so they're saying that the echo's gone.
Okay,
So even
cool.
though you're not in my off-air feed now, but you're going to have to. Oh, you're moving now.
Okay,
So there. That's because you got the screen share. Don't screen share the Skype feed, or it just goes apeshit trying to update it. Echo gone. All right. Hey, so now we're only
I'm
two
just
minutes late
relaunching.
because yeah.
I'm still launching my project in Fusion, so
So
that's
yeah,
probably slowing down my laptop.
last week the problem was that an audio driver didn't finish loading, and this week it's just random crap. So, I had a
Well, but it's
Windows
working
update and
now, right?
everything changed. It supposedly it's working now.
Okay, so you've got that board open, and I had asked you before we started transmitting. So this is for the benefit of people watching. Hi everyone, by the way. So forgive me if I'm looking sideways half the time because I have to turn my head this way to see Bill and turn my head this way to see the screen I'm sharing and look at the camera. So I'm going to be confused. So Bill, this is the 6502 Relico? Is that what that
Relic.
said?
It's Relic.
Re-
Relic version 5. Relic 5.
Oh, okay. So just on my Skype call, the resolution's not that great. So there it is, the 6502 Relic 5. So that's the board that's running programmer Frank's code with the
That's correct.
VFD
Right.
that you showed us last week, and it's still there on your bench, I believe.
Yep.
But I was
Yep.
asking you to give us a run through of the actual design. It looks, is it a four layer? It's a four layer board. So you've got
Yeah.
ground planes, so that's good practice. Unbroken ground planes.
Yeah.
Unlike the
So
two layer boards of the 80s where you just grounded things and as best you could, and we still might even have jumpers here and there, and you had to use shielding because of EMI. Like the same thing now probably wouldn't need shielding because you've got a ground plane that keeps the fields trapped in the board, right?
Yep. Plus, there's almost no noise. This is almost all CMOS, and it's running at 1 megahertz. I mean, this thing shouldn't even be a blip, actually. But
Yeah.
I just threw it on regular old ground planes. Yes, one for 5 volt and one for 3 volt, and we can turn those back on here. Again, this is Audium. I'm doing this in. A lot of times, once I've got them on, I go ahead and shut off those, and it looks a lot prettier, a lot more what I'm used to.
Well, you can see where you're routing then if you,
Yeah.
yeah.
Right.
But
Now, one of the things I did here is this header actually mimics the 6502 twice. So when I was troubleshooting, it was real easy to put my test points right on this connector right here.
Yeah.
And so if I needed pin 39, here's pin 39 on the chip, but I didn't have to get in here with one of those micro grabbers or anything. I could just shove a connector right on this post connector on pin 39.
That's cool. And I guess you can do that when you're dealing with things that are not super high speed, because you're not going to worry about the stub out to the connector creating a ton of reflection.
That's absolutely correct. And here's why I did it is, here is this. I was going to use this as a, I don't want to call it an ice. Frank pointed out I was using the word ice incorrectly. This would just be a logic analyzer for the 6502. This is a Teensy 3.5, which is 5-volt tolerant, and it's got the same 40-pin connector here. So the idea was, with just a simple ribbon connector from here to the relic, I could, use it as a logic analyzer.
How is that not the same as an in-circuit emulator, ICE, which is what you're talking about?
Because I'm not replacing the 6502, I'm just listening to the 6502.
So Frank is a very seasoned embedded developer, right? So I believe what he says.
I do too. He's absolutely correct.
The definition then of an in-circuit emulator is that you're
Whoop, we lost you. Keep talking. So we lost Ben there. We're talking about in-circuit emulators here. So the definition of an in-circuit emulator is where you would actually unplug the 6502. And the 6502... Okay, you're back. Go ahead.
Oh my gosh, this is so frustrating.
Yeah, you were gone for a long time.
AT&T. I was going to say, so the clarity there, for an in-circuit emulator, you're actually running on the same CPU target. It's just got extra hardware to halt and single step and do do instruction traces.
Right. And the actual processor sits up in the pod that you plug in, as opposed to this just listens to the bus and deciphers what it's saying. So I was trying to make a 7D02. My favorite logic analyzer ever was the Tektronix 7D02. Saved my life, threw itself in front of a bus one day to save me and mine. And so I just wanted, I looking on eBay, I can't even find the components to make a 7D02 because you need a certain kind of tech frame. Then you need the plug-in, and then you need the personality module, PM05, I think it is, something like that. And I'd never even see the personality modules. I've had an eBay search running for years, and the only thing it ever comes up with is the manual for a 7D02.
Because the people who have them don't want to let them go.
Or they've already thrown them away. Yeah.
Yeah. So I was wondering if you could walk us through the schematic, because this is a pretty straightforward single board computer, 6502 based single board computer. It's almost probably identical to the schematic of the one I did in college, which I showed in a much earlier, like one of our early streams. I was showing the WIM from North Sydney TAFE College, where I first did my associate's degree.
Right.
So walk us through. Could you increase the size of that? Because
I wanted to show you one thing first. So I had put out to the group. I had said, name two differences of the 65 CO2 from the 6502, and everybody got the bus enable pin correct. There is a bus enable pin on the 65 CO2 that didn't exist on the original 6502, and I've already put it on the schematic. You can see it here. I had actually been using it as an as a I2C interface, because if you're making your own processor, you might as well add functions on the unused pins. Well, guess what? I used a pin that's reused on the 6502. So without the bus enable pin being tied high, nothing worked. And that's, whoops, let me move something here.
I see you've got a a non-schematic schematic there.
Yeah, I cheated, absolutely. I didn't draw the buses or anything.
You could have, and this is a perfect case of why should we use schematics anymore when half the time for digital designs, you just put a bunch of rectangles with a whole lot of pins on them and you name the wires going onto them to do all the connection through net labels. And it's a valid argument. If you look at a design like this or anything more complex in the digital world, even my jogger PCB, there's analog sections where I want schematic because they convey and document circuit functions.
Right.
But for a lot of this digital stuff, it's like, yeah, this pin's just going to A0, this pin's going to A1, this one's going to A2, blah, blah, blah. It's like, why not describe that in VHDL or Verilog? I get it. It's a valid argument. And in fact, this was something that schematic tools used to have that got torn out of them by people who didn't want to maintain that code. Now, I don't have anything quite like that in Fusion. I believe that some people have written ULP scripts that will convert or translate Verilog or VHDL into a board net list, but I need to research that more. But I just think this makes this example of how you've done your schematic does make a good argument for describing some things in a language that might be a lot easier, or even a high-level block diagram, which is what I like to do. I always like a block diagram. I like to partition the design into sections that I can bite off and chew and eat the elephant one bite at a time.
And Altium does have what's the name of the connector? Not chain, not rope. It's a bus. You can use there's buses, but then
in Eagle and Fusion, it's just a bus because you can have as many disparate signals in one bus as you like. Altium never supported that, so they had to invent a higher level thing called a harness.
That's it. That's what I was saying.
Now,
bus and yeah,
is now becoming
it's a harness.
Confusing because harness implies cable, but it's just a schematic feature. It's not got anything to do with cables.
And I have done a schematic doing that where there's blue boxes for all the major portions and the harnesses interconnecting them. I can't pull up that schematic at the moment.
Well, they did the whole nanoboard series that way as a reference design, and so that's the intention. Actually, Matt Bergeron was deeply involved with a lot of that back in the day, and modularizing schematic, like making things reusable by using harnesses everywhere. Yeah. So I actually do like that approach. That's why I started my latest design. If it's an analog design, or if it's something broken up into a system, I always use a block diagram, and then potentially the block diagrams can be used to simplify the connectivity, so you can make things reusable. If you have an I2C bus, it's an I2C bus. If you have an SPI bus, like there's a reason why all these things have become kind of common or standard, is you can put a circuit element there and just say this goes to that. And I feel like we need schematic front end tools, need more love. Like ECAD, this is my personal opinion. It doesn't represent that of Altium or Autodesk. But it is that companies that develop ECAD have focused so much on PCB routing that they've neglected the engineering side of ECAD, which is the schematic and simulation, for a long time. And I think it's time that we made some changes and improved schematic drawing capabilities and front end design entry, which may not be schematic, it might be Verilog. So anyway, I'm waxing lyrical. I'm sorry. I'm going.
Well, you touched on a sore subject for me. Altium, I don't work for them, so I can freely express my opinion, is tedious to do buses or to do repeating signals like what you have on an EEPROM and ROM. compared to something like OrCAD. And what I'm talking about is when you go to number these things, in OrCAD, I can tell it I want to count down from A14 by every other number, and I'll go A14, A12, A10, A9, A8 as I'm dropping them. And on Altium, I have to basically sit there and name each one.
Oh,
You know, there's an auto increment,
okay.
but you can't tell it to auto increment by 2s or by 3s or what to start with 12 or anything like that. And you used to be
Right,
able to
yes.
do it in OrCAD.
Okay, I haven't used OrCAD since it was still running on DOS, so I can't speak to that for OrCAD. For Altium Designer,
Well, OrCAD's
Those-
fast. I can scream in
things-
OrCAD.
those things are there. You just need to know how to find them. And in Fusion and Eagle we have bus breakout features. So you can actually zoom into your EPROM there, the 27512. Zoom into that, or the 256. So if I have a part like that in my schematic, I can right click on the part and say bus breakout, and it'll add what you see there, all the wires with the net names, and I can say take the net names from the pins, or I can say, take them from an existing set of bus signals on the schematic. So it does help speed things up a bit. It's not useful in every single situation, but so I normally start with the bus because I know I'm going to have, say, 16-bit address. So I'll start with a bus wire object and name it as a open bracket 15.0 close bracket.
Right.
And then the system knows that's a 16-bit bus with indexes from 15 down to 0. And then I can draw that as a bus wire right down next to the chip, and then right click on it and say bus breakout, and pick a subset of those bus signals or all of them, and it'll add the wires with the net labels onto it that I can hook straight up into the chip. And normally the symbols are drawn so things are in order, so it all lines up nicely. So but you've got to think about these things ahead of time. Then certain areas of schematic design can be very, very fast and easy.
Yeah, repetitive tasks.
Yeah, anything repetitive needs to be automated in CAD. That's just my philosophy, and that's why I came to Autodesk as a product manager. So I did marketing for so long for Altium, and I knew the tools so well, and I could make them really dance, and I can still design stuff like exceptionally quickly because I know the tools. What I couldn't do was, or what I found frustrating was, I didn't get to influence the order of development or the priorities of development for fixing or improving some of these things. And I got frustrated that I didn't have a say in what we were working on. I just had to go talk about it and sell it to people.
Right.
Well, I don't mind talking about something that I agree with, but if there's something that I think is more important, and so at the same time, the customers also, need to share their opinion of what's important to them and what makes a difference to them, and so that's why I moved to Autodesk. But anyway.
So do you have an auto increment label? Like if you create a label in Autodesk, can you make an auto increment or an auto decrement label name, like 15:0 or 0:15, and it would auto label?
Well, so in Altium, you could type in you could place a net name, and you could type the name in, and if you put a 0 at the end, you click, it'll put the 0, and then it automatically goes to 1.
It's an auto increment only.
So you could just keep clicking, and it will always go up. You can't make it go back.
And OrCAD, you can go down, or you can count by a modulo.
In Fusion, we don't. Now, I could be wrong because I'm still really learning the tool. In Fusion and Eagle, there's not an auto increment like that. I believe that you can enter the place command in a way that it will do it, but I'm not sure. but the way you do that is different. What I do, as I mentioned, is I define a bus first. I name one thing with the bus index, and then I can break it out. And that's, instead of click, 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 it's, okay, I've done that. Now it's right click, bus breakout, click, done. I get all of them, right? So it's just a different way of doing it. But to me, it's faster.
You can even copy paste in OrCAD, the old OrCAD 10. You could grab a bus of 4, copy it, and then when you paste it, it's 5, 6, 7. And you paste it again, it's 8, 9, 10, 11. You know, so it can auto increment pace. You know, so doing a bus, when you copy a bus, it'd give you a choice. Do you want to use new labels, or do you want to connect them to the exact same bus, A0 through A15, for example? But it gave you a choice, and it was very fast and intuitive to do.
Yeah, I think Smart Paste in Fusion and Smart Paste in Altium are similar to that.
Right.
So they both have a Smart Paste. So, yeah.
So the other difference in the 6502C that I've been alluding to, let's see if I can, is that they made a pull-up go away. Now, again, normally I tie off all pull-ups, right? But this was a 3-volt part in a 5-volt circuit, and until I added pull-up resistors, I didn't have to worry about 5 volts, so I cheated. I let one pin float, and here's the difference.
Wait, so what you're saying, the 6502, the NMOS,
had a pull-up.
No, it had an external pull-up, or it had one in the chip?
It had one in the chip.
Okay, right. On which pin?
Well, that's what I'm going to show you here.
Okay.
So see the speed of the scrolling text there?
Yeah.
So I'm going to remove the pull-up. And see what happened? It's way slower. So it's the ready line. It's stopping doing a wait cycle.
Oh, that's crazy.
So when they did the 65 CO2, they removed the pull-up just because. I don't know why, you know. So, you know, it's kind of like a song, right? You don't go changing the words to a song. You know, unless it's English Rose or something, right? And there's a reason to do that.
Well,
same thing with the.
I can see why they might, though. Was it a weak pull-up, a very weak pull-up? Because
it probably
resistors in silicon take up a lot of space.
Well, they suck. NMOS resistor is just a piece of poly, basically, or it's a transistor, right? But you got to get the gain of the transistor right to act like the right amount of resistance, and those guys do know how to do that. But anyways, that was, and so when I was troubleshooting this, I found the missing ready line pull-up before I found the BE line, you know, because I went back to I finally said, oh, you know what, I better look at the 65 CO2 data sheet, because I didn't design it for the 65 CO2. It wasn't even on my radar till I went to get a 6502. And again, I could have put one of my 40-year-old 6502s in there. Why bother? I just grabbed a new CO2, right? So that was the other one.
How fast can the WDC 65 CO2 chips go? What's the maximum clock you can apply to those?
I believe 4 megahertz. Yeah, or 3.5 if it's this hand. 4 megahertz.
I wonder if has anyone tried overclocking them to see how far you could get?
Oh yeah, they do. Yeah. And there's some projects out there where they're trying to do the stuff, honestly, without doing the calculations. They're just running the clock speeds up, seeing how it works. And I'm like, If it doesn't work on paper, the one on your the one on your bench. Well, if you're trying to get one working, absolutely go for it. But if you're trying to design something that you're then going to build 100 or 1,000 of, if it doesn't work on paper, it's going to bite you when you do your production run.
Oh yeah, yeah.
So I am big on getting all the values, all the setup times, hold times, all that. I am real big on that.
Yeah, I think the actual package is a considerable limitation, because you only have how many ground pins are on it? One? There's one ground pin?
Yeah, basically, yeah.
one ground, one VCC, and you're forcing all the signals that switch all at the same time all share that one ground pin for their return.
It's actually 2 ground pins, but they're nowhere near the VCC pins, so you get that inductance from having a big separation of ground and VCC also.
Right, well, and that ground and VCC separation was done back in the day to facilitate board layout, because there were 2-layer boards with no ground planes.
Right.
So,
I heard somebody think
had that scheme where you had VCCs on top and grounds on the bottom.
Oh, they used to do interdigitated and all kinds of. I heard somebody thank Bill Minch for making the VCC and ground pins the way they were, because when they put in the wrong chip, it wouldn't burn them up. And Bill's like, oh, we kind of did that on purpose. And I'm thinking to myself, yet we didn't know about putting VCC and ground next to each other so that the inductance is lower. You know, they would feed the corners of packages. Think about it. TTL still does.
Yeah. At least the ground usually forms the platform of the whole lead frame. But still, you're forcing all the return paths through one little pin.
Yes.
So crosstalk.
It's
and
inductance. Yep.
That's
one little common resistor.
That's your physical. That's your physical limitation as to how fast you can push anything in a dip 40. Whereas if you do like what you've got there with the Teensy or the Cyclone 10 board, and you put your 6502 into an FPGA, then you've got grounds and powers interspersed all throughout the package, and you still have that neck down for the socket that it's going in.
Right.
But internally, at least, you can run much faster. So.
Right. So, getting back to the design, I don't know what else to show. You know, it's a ROM, it's a RAM, it's the processor.
And your ATF16V8B for memory mapping.
Yep.
And what else? So, how would one take this single board computer and add other stuff to it? Because the beauty of a single board computer platform is it's like the single board computers were really the predecessors to modern microcontrollers, where you take this thing that's kind of general purpose, but small enough that you can mount other things to it and bolt things together, and before you have it, you've got a full custom system with whatever IOs you need. And like, how do you expand this by hooking up directly to the 6502?
So
package?
what you would do is you would, just as this ROM right here has all the address lines and all of the data lines, and then here's the RAM, address lines, data lines, and one extra signal, the write enable line. Well, what we do then is we select them with the ATF16V8, the IO selection or RAM-ROM selection. So to add a part to this, I would first go into the memory map and figure out, okay, at E40 or something like that, E040, maybe I'd have a new I/O device, maybe a sound chip. And I would first start by making a chip select for it, and then I would hook it to the bus. So really, this is the traffic cop right here, this guy. He decides, first off, he makes a nice, clean write enable signal. And it's worth talking about write enables for a second. Address is set up first, and addresses have to be valid before the write enable goes low, but the data has to be valid before the write enable goes high, right? But if the addresses are changing when the write enable goes low, you cause internal collisions in the RAM chip. Different rows and columns start coming on the bus, and you're in effect trying to write to multiple locations at once if the address lines are wiggling when the write enable goes low. And this is a real important area in especially 6502 design. You have to clock your write enable. You can't use the read-write line out of the 6502 as a write enable on a RAM. You just can't do it. Because the write enable starts twittering and doing things at the same time the addresses are setting up. It's setting up. So it might even
Oh.
glitch or something. So you have to wait for the clock to come along and says addresses are valid. So's the read-write line, by the way. And so inside my ATF16 V8, I clock qualify this signal called write enable. So up until then, it was a read-write line. You can see it here on pin 12. That's an input actually going in. That's read-write going in, and a clocked write enable comes out. I also clock qualify the IO select probably. I don't remember. No, not for the 6522. I don't. Some I/O devices may need to have a clean clocked write strobe as opposed to a read-write line.
Could you explain something else to me about 6502 architecture in general? Something
Sure.
that really annoyed me was having to have a two-phase clock. Why couldn't they have designed it with a single?
They don't use the
Clock
second
input.
phase. There's that phi 1. Nobody uses phi 1. So phi 0, here's how to use the clocks on a 6502. Phi 0 is the input. Phi 2 is the
Isn't it-
input.
Yeah. Is
Go
it
ahead.
just inverted?
No, that's
Is
what I'm trying to say.
Is it 90 degrees or
No,
180?
that's what I'm trying to say. So phi 0 is the input. Phi 2 is about 10 nanoseconds later. It's just the thing about it is it's one delay, one 6502 delay, so it's exactly in phase. It's what you base the timing off of. So when it says address setup, they're comparing it to phi 2. So there's a signal called, there's a spec called data hold, which is after phi 2 drops, you have to keep the data stable for 10 nanoseconds afterwards. Well, wait a minute. What if I have too much logic in my phi or in the clock circuit for that? You can use phi 0 as an early clock. So there's only 2 clocks in a 6502. Everybody uses phi 2 in normal use. Phi 1 is an inverted one. Nobody uses it. We thought it'd be nice for logic and stuff, but in days when you need to do gating and the TTL chips were too slow, we would use phi 0 because it was 10 nanoseconds earlier. So the answer is
that would allow, so the phi 0 goes into the 6502, but you would use that as a reference for external chips
if I had too much delay on the clock,
to allow them
two
to
levels
set
of
up
delay.
in time.
Right.
So the actual clock that the internal CPU is driven off is which one?
Phi 0. Phi 2 is an output. Phi 0 is the input that drives the whole 6502.
So wait, there's a phi 0, a phi 1, and a phi 2. Phi 1 doesn't get used.
Phi 1 doesn't get used, and it's 180 degrees out of phase of Phi 2.
And
But
phi 2 is 10 nanoseconds later than phi 0.
Typically on an NMOS part, yeah.
And that's the one that you send out to the VIA, right?
Yes.
Is that
Yeah,
what you used there? Because
yes.
that gives the VIA, that allows the 6502 to set the bus up before the VIA clock is sampled.
Right, because there's no delays, right? The 6502 is listening to Phi 2, the read-write line, and the address and data lines. It's got the internal circuitry to clock qualify it, so it goes, Phi 2 just went, I'm good. Meet the data setup time or data hold time, and I'm still good. The other reason I use just Phi 2 and not Phi 0 is when doing this, where I've got an FPGA version of the 6502, my Phi 0 is really 12 megahertz or 12 megahertz in this case. So I based everything off the output clock because there is no input clock. The input clock is actually on the FPGA board. Now I'm going to change that and phase lock it to the input. So if there is a 1 megahertz input, it'll phase lock to it. And if it isn't, it'll just free run. So that was the idea back when I did that.
Oh, that's cool.
Yeah. So, and then and then what it would do is change the internal clock based on the address it's going to. Is it going to a fast internal device or an external slower device? That was kind of the concept of it.
When did you design this single board computer? Because this is still pretty new, right?
Yeah, right before the pandemic. Back, yeah.
About a year ago.
Yeah, year and a half, 2 years
and
maybe.
Then it sat in a box until we started talking about this stuff.
It sat
right?
in a box. Yeah, I didn't even bother. Well, I still wouldn't have if Frank hadn't done some code for me because I did make it run with what we call a no-op ROM.
Yeah.
All
Oh,
I did
yeah.
was I filled the ROM with EA, which is the opcode for no operation.
Yeah.
And I put a scope on it, and I saw EAs on the bus. I'm going, it's working. I stuck it in a box.
The basic in circuit test.
So, hey, you got a PC board in, didn't you? Is that something you want to show?
Well, I haven't unpacked them from the shrink.
Well, hold
wrap
up the
yet.
package.
I'll get it. It's over in the cupboard though. I've got to step away for a sec.
All right.
Talk amongst yourselves.
So, yeah, so data hold time on a 6502 is vital. You have to, the 6502 will only hold data for 10 nanoseconds after the feed closes. And that only gives you 10 nanoseconds for a device that needs 0 nanoseconds hold time. You need to be able to shut off that device or deselect it within the 10 nanoseconds after the cycle. It's called the hold time. So now what kind of, you've still got yours in a package, right? You didn't want to expose yours to the air. Is that correct?
Right. Now, I'm not doing this to advertise these guys.
Oh, go ahead and advertise
them. I'm doing this to say this is an experiment. I've never used them before. They seem to have a pretty good website. It's very similar to PCB Way and some of the others, but their intro pricing was pretty cheap, so I thought I'll give them a try. So this is an experiment, and we'll know once I've assembled the first one or two of these if the quality is really what it looks like. But these came, I guess I paid for the DHL shipping, so they came very quickly. The actual cost of these, I got 5 boards of 4 layers, and with the DHL shipping, it was like $67.
Okay.
If I'd gone with China Air Post and waited 45 days to get them, it would have been closer to $30 and 20 something dollars to buy 4-layer boards. So it's super cheap, but I can't really see a lot through the bubble wrap, and I didn't want to let these get moisture in them until I've got the parts to start assembling them. I'll try and see what that looks like up close.
So what's the size of it in millimeters? Do you have an estimate?
It's about 142 millimeters wide and about 74 millimeters high. So
142 and what?
74.
All right, I'm just doing a quick.
If I'd kept these under 100 by 100, they would have been significantly cheaper again. In fact, I'd be probably, as an intro user, probably just paying for the shipping and not much else.
Right. So from JLC PCB, they're $40, not counting shipping. So that's probably the same price that you got.
These are a bit cheaper than JL. I looked at JLC and I looked at PCB Way, and Next PCB were more aggressively priced than both of them. But so far the quality looks pretty good. Just looking through the shrink wrap, it doesn't look like much on the webcam, sorry. But the silk screen is quite clear. The solder mask openings are very crisp. So I'm feeling like it'll work well, as long as I haven't made a fundamental design error.
So what kind of finish do you have on it?
I haven't programmed an FPGA in a long time either, so it's a very ambitious project. But the first step will be get the FPGA and the ESP32 working, and then get serial flashes working, and then get SD-RAM controller working, then get audio I/O working, and then probably finish up with the TFT panel.
Now, how are you going to build it? Were you going to build it all at once, or were you going to build the sections you just talked about one at a time?
I think I'm going to I haven't fully decided yet, but I have the idea that I will partially assemble the first one just with the FPGA, the JTAG connectivity, the basic stuff, just to
Get somebody home.
Working.
Yeah.
Yeah, I will most likely, because it's going to be hard to hand solder, I'll probably put all the passives on, regardless. All the resistors and caps are going to go on anyway, and I'm going to do those in my oven. And then I'm thinking for the first one. Yeah, I can't really decide. It might just be easier just to do the whole thing, because if I don't program the FPGA pins, they stay floating at high impedance. So I can have the SD RAMs there, and they're connected to the FPGA. But if it's unprogrammed, or it's not programmed to use them, it just ignores. Like, they all just get ignored. They're powered up. They're taking some quiescent current, but nothing else is happening. And that's kind of what. That's one of the nice things about FPGAs is you can hook up a lot of stuff to them, and then this can also be a flaw, but it's a benefit as well, that you can hook stuff up to them and worry about it later.
Right.
And just sort of work on the programming bit by bit. And then the downside where that can bite you is you could design the whole hardware and hook everything up to it, and then discover somewhere in that the FPGA place and route can't do everything that you've hooked up to it. Right.
That's a balancing act. Yeah.
It would place and route better if things were swapped around a bit. And so that's where, working with FPGAs, you end up with PCB design revisions, or putting a bigger, more expensive part on the same socket.
And we talked last week about doing pin swaps and everything to that end. Yeah. So you said that you didn't get a stencil with this. So how were you going to manually apply solder paste or get a stencil?
I thought I ordered the stencil, but somehow I didn't select it. So I had to go back and order it separately, and I'm paying a bunch
separate
more
shipping.
Again
Yeah.
for shipping. The stencil's $10 from any of these, from PCBWay, Next PCB. They're all $10 flat fee for a stencil, not in a frame. But the shipping is going to hurt. It's like $30 for shipping. So ouch.
It's the
I
same
probably
amount.
should have gone to Osh Stencils. Maybe it would have cost the same, and I'd have it sooner.
Osh stencils can cost a couple $100. Unfortunately, they're expensive.
It can, but it's only for me. I've discovered stencils get very expensive if you want it in a frame. But if you're doing it by hand for a prototype,
yeah, here's a frame. This is what we're talking about with the frame, is where the actual mine still has plastic on it. It's not even been used.
Yeah, the frame. So the frame is for when the stencil's used in an actual machine. So people use frames for hand stenciling too, but
that's what I do. I have a stencil. I have a stencil holder that actually
pull it down. Lift it up. But the frame normally is used in a solder paste dispensing machine. I'm not intending to go to mass production for these, and if and when I do, it will be using one of these services. I won't be manually configuring all that stuff. I'm only going to prototype it. If this becomes a product, and I actually hope it does. I hope this project takes off and people want to contribute to it. And if I end up selling it on Tindy or whatever, then I'll have someone else do the assembly.
So here's a large stencil, and you can see just a little circuit in the center of this. This was a listen attenuator, I think. 10 dB attenuator with voltage clamping.
So that one's not in a frame.
Right, it's just large.
Yeah.
And sometimes you get these and they're just the size of a postage card.
Yeah,
depending
which
on.
is what I actually, honestly, I prefer it when they're
Yeah,
cut
I
down
do too.
closer to the size of the actual board. It's easier to set everything up.
Here,
So the trick
here's
you
one
get
of those.
You get other, yeah, exactly. That's how I like it. So you get other pieces of printed circuit board or the breakaway tabs off the boards you've had made, because they're the same thickness or close to the same thickness, and you tape those down to the desk, right? And then you tape the stencil over that. Well, I always tape the two boards, like, imagine like this is a board. So I tape two of these at perfect right angles to where the board I'm stenciling goes up into the corner against them, and then I tape the stencil over that on one edge, and then I can lift it up, slide a board in there, put it down, squeegee it, lift it up, take the board out, and I can do I can place all the parts on it and then come back and do another one while the solder paste is still fresh. But yeah, this hand dispensing with a syringe was never appealed to me. The first time I saw that, I thought, yeah, I don't want to do it that way. I'm going to end up with globs of crap everywhere.
So I have an auto dispenser and I don't see it. I have a vacuum pickup tool and a foot operated paste dispenser. And the problem I had with the foot operated paste dispenser is the paste wouldn't adhere to the PCB easily. So you would try and make a squish where the paste comes out of the syringe, and sometimes it would just curl up and not stick to the PC board, and then you have to clean it off and do it again, because otherwise now you can't stick it to the next one because you get twice as much paste. So yeah. I did try that. I did go that route, and I got some things to work, but I prefer a stencil overall.
Stencil's the only way to go, honestly.
Now, what kind of finish did you get on your PC board? Is it Enig or what is it?
Well, I just went with the cheapest because this is the first prototype run. So it's actually tin lead hassle.
Hassle?
Hot
hot air surface layer. Yeah, surface level.
Hot air solder leveling. Yeah.
Okay.
That's where the whole board goes through.
I knew I'd get it wrong.
The whole board goes through a molten solder bath, like a wave soldering machine, and then past a hot air knife that blasts off any excess. Yeah.
Right. So just for grins, I punched in your PCB dimensions in the PCB way, and it came up $92 without shipping.
Yeah, that's about what I got.
So it's about 3 times the cost, 2 to 3 times the cost of JLC PCB right now, unfortunately.
Yikes.
And it didn't used to be before the pandemic. PCB way was cheaper than JLC PCB.
I'd be curious. Something I was thinking to myself last night as I'm looking at my bill of materials, which is here, right? I'm sharing that. Well, you should be seeing that. There it is.
Yep.
And I was going through this list, and you know, some of the key components I purchased ahead of time, like the FPGA itself, and the ESP32 modules are easy to get. But do you think I could get an FT2232 for love or money right now? Not a chance. It's crazy. And some of these other parts, have become really hard to get. These the audio codecs, they're easy to get on AliExpress, but it's, they're dubious sources. You're buying leftovers from other people's production runs. I don't know. I probably should bake them. Probably should bake most of the components I have for this, because they haven't been in airtight, dry packaging, and I don't want them to burst when I put them in the oven. I've got 2 of the FPGAs, and I was looking, well, I should get some more in case I ruin something, right? They're $17 each or $18 each from the Lattice website. and Lattice uses Mauser and DigiKey and Arrow for their samples. So it looks like you're on the Lattice website and you're buying from Lattice, but they sub it out to one of the distributors who keeps the stock. None of them have stock, at least
Right.
not of the HC variant. They have the HE variant, which uses a lower voltage core, and they're maybe $1 more or something. But
You're absolutely right. Look at the screen. Here's DigiKey, and look at all those zeros in the column for.
Every FTDI, and I went to FTDI's website to see, well, maybe they sell some samples directly, and I'll buy a couple straight from FTDI in UK. And do you think they have? No, they do the same thing. They all go out to the distributors, and all the distributors for the FTDI chip are depleted. So what I ended up doing was buying another FTDI JTAG adapter from AliExpress or Amazon or somewhere, and I'm waiting for that to arrive. And I'm going to leave that chip off the board and just go wire it into the header position, because fortunately I had the presence of mind to put the JTAG signals out to a header as well as go to the chips. So what it means is, if I can't get the FTDI part yet, and I don't know how I'll solder it later, probably just use hot air from the gun to put it on separately after everything else is already on the board. It's such a hassle. And what if the next thing I want to do is make 100 of these and sell them on Tindy? What am I going to do? I can't. It's like everyone has this problem right now.
Right.
Some of the most
There was
basic
one of
parts
them.
are
Looks like you can get them on a reel, but I haven't looked to see how valid that part number is or anything.
Well, it might mean a respin on the board too, because maybe this 64 TQFP is not available, and that's the most popular one. But there's still some DFNs or QFNs, so I'll have to redesign the
There's
board.
some It's a 32 QFN. Yeah, that's available.
So I have to redesign the board to use the QFN 32 and probably one or two other things will matter. So now I have a respin because of part availability, not because of an error.
Right. It's a pandemic special. You know, it's like having to redesign. And I used to do that for production, is design, making absolute sure it was a common available part or even in stock already. Designing for what's available. We haven't had to do it for years, and now that's the reality.
Yeah.
My wife's trying to buy a car right now, so we're going through this.
Too.
Yeah. Her lease ran out right in the middle of this problem, this shortage.
Yeah, that sucks.
So we got a question.
Inflated.
we got a great question about how's the flatness for hassle for hot air. I'm going to call it surface leveling again.
It's not optimal. It's for flatness, your best is ENIG or NEPIG, which is the electroless nickel immersion gold, because that's a plating process. It has much more even, pretty much perfectly even surface. Hassle, because it's molten solder that sticks and then it's blasted off. So it has. Now, if I look at this through the plastic for next PCB, their hassle, it looks very even, but I can see some non-uniformity. If I hold this up in the light, I can see some slight non-uniformity in some of the bigger pads where there's
right.
Where there were dollops of solder, but
and the main thing
overall pretty good. So
and the main thing is a big chip like a TQFP 144. It's not going to sit flat enough for all the leads to exactly solder correctly. But my experience is
that's never the problem, because the solder paste is thick enough. Yeah.
Well, I couldn't even get them to sit flat. So I was going to say I've gotten hassle to work with all the smaller parts, 32 pin parts, all those. I've actually gotten hassle to work. But when it comes to big parts, what's that?
Not with a 144.
I think it was problematic. I couldn't even get it to sit flat, is my memory. You know,
Wow.
when I dry sat it.
I could see that potentially when there's before the solder paste is there, but we used Hassel for decades
We did.
before lead became a problem with Rojos and Reach, and that was only in the early 2000s that Rojos became a thing, and then I think it was probably around 2008 that lead was finally outlawed. Other than if you're prototyping, you're allowed to use lead solder, no problem. It's if you go to mass production and then sell this as a consumer product, then it's a problem. And that's right, military and aerospace were given a leave to do what they will because lead solder doesn't fatigue or cause problems in high vibration environments or temperature fluctuations.
Right, right.
So it's more reliable. So for high rel stuff, lead is allowed as well. But we used it for decades on computer motherboards with big BGAs and big QFPs and other things. I think the solder paste goes a long way to help even things out. But then when you're hand prototyping, of course, then you have to watch out for bridging and stuff. But nothing a bit of wick and some skill can't deal with, I suppose.
Right, right. So, all right. Well, we're running out of time here. Any last comments or words? I just wrote down to maybe next week I talk about pick and place a little bit, if that's of interest to people.
I didn't generate the file, did I? But normally, so I was going to say about pick and place too. I don't hover over generating a pick and place file and getting. I've never been concerned over it because I've just discovered that the people who have pick and place machines need to care about it, and I don't have one.
Right. Well, there are some. If you've got $2,000 or $3,000, there are some interesting pick and place machines that are visual, like camera based.
I've wanted a light placer since I saw one for the first time at Maker Faire in Bay Area Maker Faire about 5 years ago. The guy that designed the light placer was there showing it off, and I'm like, this is a kit pick and place machine that is visual, like it at least rotates the part based on machine
over a
vision.
Camera, yeah. And
this would save me so much time, but even that, as a very small pick and place, quote unquote desktop pick and place, requires about 1 square meter of area, which I don't have. And then there were other ones I saw from China, the little ones that come with some side-mounted reels and rails, and they're about this big, cross-sectional area. And they're more expensive. They're like $2,000 to $3,000. So I was like, I
wanted one.
Another electric guitar.
Yeah. I wanted one, but the reality is it takes time to still set it. Getting a pick and place machine doesn't mean your first one is done quicker. Your first one's done slower than if you hand placed it.
You've actually just made more work for yourself. And there's actually, I highly recommend this video, and this is someone I'd love to have on as a guest about all this stuff. There's this electronics engineer in LA. He mainly produces custom camera equipment for the film industry, and he's got a website called Factory 400 if anyone wants to look it up, and he's done some videos explaining how he turned his garage into a 400 square foot electronics factory. He does all the engineering and design work. He does all his own inventory and his own pick and place. He got a pick and place machine that's not one of the latest ones. It's kind of a smaller one that's kind of slow, but it's enough Like if you were setting up a business to be a small business boutique electronics provider, it would be perfect. And he actually said in one of the videos, I didn't use the pick and place machine for this job because I was only making 10 of them or
Right,
15
right,
of them. And
right.
it was actually faster for me to hand place the parts and just get the job done than to reconfigure the pick and place machine for this small job and then have to reconfigure it back again for what it normally does. So, yeah, but I think there's probably some balance and compromise. And this is why I always really love the idea of, couldn't there be a factory? And this is probably how JLC PCB does it, right? How can they offer assembly services so cheap? Well, it's by limiting the parts you can use. If you use anything from their bill of materials, their library in Easy EDA, which I found to be quite limited, but like it just, the theory is right though. If you have a pick and place factory set up with a fixed bill of materials, and those, you ensure that those parts are always on the reels, ready to go.
Right.
And anyone can build a product using any of those parts that are always on their line. Then not every machine will be in operation for every board that goes through necessarily, but let's say you have 3 or 4 pick and place machines and maybe 150 or 200 parts in the bill of materials of what's available. If you can design anything with just that small set of parts, and a lot of things can be designed with that set of parts. So they always have an Atmega 328P at 32U4 microcontroller. They always have some kind of STM32
0.1 microfarad caps. Yeah.
All the normal decoupling caps, most of the common resistor values, and all of that can be known ahead of time. Like they've done the analysis. We know what parts are consumed in on average. We know the power law distribution of which parts. If you just stick to the most popular parts on a pick and place line, in theory, you have that one library. If you design anything to that library, it can just go through without any setup overhead. All you have to do is make sure the design, like the pick and place orientations and locations, are correct. And everything else is already just there and optimized. But this is why. Yeah.
Somebody asked if that guy is trying to run all of that by himself, the Factory 400 guy.
Yeah, he does everything himself.
So there's another company, Small Batch Assembly. I think it's smallbatchassembly.com. Yep. Bob Cogswell, he's a co-author on the sudo command in Unix. He worked for Bell Labs back in the old days. So, but yeah, and he's got a real pick and place machine, I believe, you know, which honestly, there was a while I had an eBay thing where I was watching real pick and place machines, and they're available for a couple thousand. You just got to get them. You got to go pick them up.
That's it. They'll be sold by some factory here or in China. I had an opportunity to even Altium had a small pick and place machine. I think it was the same one as the Factory 400 one, which they had bought and shipped to Sydney, and then the company moved headquarters to Shanghai, so they shipped it all to Shanghai and set it up and they were up on the 10th floor of some building, and the building wasn't rated for any kind of factory equipment, so they couldn't bolt it to the floor, and they couldn't run it at full speed. They could only run it at a snail's pace compared to what it was capable of. And they had a hardware team, and it was all set up just for prototyping stuff. And none of that went anywhere. And then a change of leadership occurred, and all that stuff, they needed to get rid of it because they're like, hardware is not what we do. It's what our customers do. We don't do it. We make the software. So they had to get rid of all these parts, and the guy in charge of offloading all that said, basically, this is, if someone doesn't buy this, and we almost are willing to give it away, it's probably going to go to landfill,
right,
or some kind of recycling. And I'm like, oh my gosh, you know, a pick and place machine that once upon a time somebody spent $60,000 on it, and you're telling me I could have it if I could organize shipping to get it from Shanghai to the United States, and I'm like, oh, I should do this. I make a space for this in my garage. And I'm looking into all the shipping logistics, and it was too hard. If I really wanted to do it, I could have done it for probably under $10,000, and most of the cost would have been in shipping. And then my concern was, well, I might be missing parts or missing cassettes, or the PC that was set up to run it will be left behind, and I won't have the software, and I'll have trouble getting it. All these big question marks came about. If you're not someone in that industry who knows where to get the information, if you haven't worked for a manufacturer, so there's design and there's manufacturing. If you haven't worked in the manufacturing part of the electronics industry, it's really hard to know where to get the things you need to set something up and have it actually operational.
Right. But, and I came from production, but it was back in the hand assembly days. And one of the things they brought in before, actually, what we call it, wasn't pick and place. It was just auto insertion. Before auto insertion, they demonstrated a machine that had a laser, and it would go to the bin of the resistors, and then the laser would go to the two holes that you're supposed to put it in.
Tell the person where to go, and it would you can still buy those machines, because there's still some things can only be hand assembled, right?
Yeah. But the assemblers were so good back then. I mean, they're using their lead benders and dropping them in, and we hand assembled all our PC boards back in the late 70s, early 80s.
Yep.
For instrumentation. So, hey, it's 6 minutes past. Any closing words?
Well, no. Like always, we thought there's always more to talk about, isn't there? So
there is.
Next week, and hopefully I'll have sourced some of the parts I need, and at least I don't know how I'm going to find the time. I just have to stay up late at night or something, but I've got to get something working on one of these boards to show everyone. So,
have you thought about getting the kids to do the assembly for you? Any chance of teaching them?
I could teach them. They're out right now at a summer camp, but they'll be back next week. So maybe it's just hard to get them. Like they'll say that they're interested, and then they'll want money for it, and then and then I go, you know what? I don't want to do that. I'd rather go hang out with my friends. Right.
Yeah, I offer my son money to try and correlate. A good day's work is worth your time is worth money.
Yeah.
So I don't mind paying my boy to do that. So
I'll probably end up doing that. I think that's a good idea. I'll see if any of them can be convinced.
Right.
Yeah.
And I can't get my son to use the microscope because his eyes are too good. He does it all by hand, whereas I do all my assembly under a stereoscope, an X10 stereoscope.
Yeah. Well, that's something else I've been wanting to talk about again. We've talked about it briefly in terms of test instruments, and eBay is the answer, of course, if you want to establish a lab with some decent test instruments. eBay is probably the easiest way to go, even though there's inherent risk. But it might be helpful to talk about some of the ancillary things like microscopes that you need. I got a USB scope some time ago. I don't have it in my possession anymore. I need to replace it. But I would consider the next hand pick and place job to be done using a big monitor and a USB microscope.
Right. So Wes said he'll do the assembly for you if he was in California. So
yeah.
Wish you
were here, Wes.
Yeah, wish you were here. I was just thinking of Sid Barrett earlier today. So I wish you were here. All right. Thanks, everybody, for showing up. Good talking with you again, Ben, my friend. And let's do this again next week.
Cool. Yep.
All right. Take care.